Welcome one and all to the lesson on oblique triangles, where you will learn to identify the different components of it and recognizing when to solve it. So what are oblique triangles? Well, simply put, it is a triangle that is not a right triangle, meaning there are no angles at 90 degrees, which also means that unfortunately you cannot use the Pythagorean theorem to find a missing side given two of them. Now it is important to note that a side corresponds with its opposite angle. So for example, we have side A corresponding with its opposite angle of A. We have a side B opposite from its angle B, and so on and so forth. Now, this is the main premise of the video. When can you solve a triangle? So first off, what does it mean to solve? Solving means that you know all three measurements of the sides and all three measurements of the angles and given one triangle. And you can do that if you're given at least one side and any other two measures. And this leads to four possible cases. But before I can even show you what those cases are, we need to do a quick recap on different terms and axioms that you might have learned in the past. First thing is congruency is when you're comparing two different objects, they're identical in form of measurement. So if you had to compare two different triangles, all three sides have to be the same and all three angles have to be the same. And that leads us to the congruence axioms, where if you had to compare two different triangles, if you're given, in this example, a side, angle, and a side that they both share in common, they're congruent. However, this video is not focusing on actually comparing two different triangles. This video is knowing when to recognize how to solve one triangle. So if you're given one triangle, this blue one, and I'm given a side A, a side C, and the angle between them, or included between them, is B, I can use these three measurements to find the three missing ones for that one same triangle. So side, angle, side, or SAS is one of the axioms you need to know. The next one is side, side, side. This is pretty straightforward, where it's just you're literally given three sides to a triangle. Excuse me. Next one is angle, side, angle. This is where you're given two angles and the side between them. So in this case, angle B, side C, angle A. Angle, side, angle, ASA. This next one is a unique one in of itself. Side, angle, angle, or SAA, or if you read it backwards, AAS. So this is the first one where reading it backwards makes a difference. The reason why this is unique is because this is just a different form of the previous one I just introduced, ASA. The reason being is that this one does not have the side between the two angles. Instead, it's after or before it. However, you can rewrite this into ASA. How? Well, the answer is right there in the middle. The angle sum formula. A plus B plus C equals 180. What that means is this. If you're given two angles, you can always find the third angle because all three angles added together in a triangle will always equal 180. So once you find that third angle, you can rearrange it so that instead of writing the triangle as side angle angle SAA, we can use angle side angle instead, the ASA. And depending on the cases in the future, you'll learn to recognize which one's easier. Now, this one right here is one of the false congruence axioms. So if you, again, were trying to compare two triangles and you were given side, side, angle, which is acronym of SSA, if you read it backwards, ASS, which I will not say out loud, this does not prove congruency. However, when it does come to solving the triangle, it is possible. It's just this one's very unique because it produces ambiguous cases. How are those ambiguous cases made? Well, it's from that one side that you don't have. This one particular side that you're not given has a lot more flexibility of what it could be. Therefore, it creates these cases within itself that will be presented in a separate video when it comes to solving this particular axiom. Okay. This last one, AAA, angle, 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 is not able to even prove congruency, nor are you able to solve a triangle either, because you're not even given a single side. So this one is something you just completely ignore. And now we're back to introducing the 4 possible cases. How can you solve one triangle given one side and any other 2 measurements? Well, here are these cases, and each of these cases or groups of cases will be presented in another video. So case 1 is where you are given a side angle angle or angle side angle. The commonality between those two is that you're given at least, or you're given 2 angles. Case 2 is the ambiguous one. Case 3 and 4 share a commonality where you're given at least 2 sides. So now you have the information to recognize when and how, when to solve oblique triangles, and in separate videos you will learn how to solve each case.